There's quite a degree of geometrical complexities there, but it's minimised by allowing quite a decent amount of repetition, and I guess structuring that in a mathematical way. So I guess repetition is a big part of what you do with automation to automate that repetition. You mentioned the use of colours to drive facade types. In last year's Year in Infrastructure, you presented a project using this approach. Can you tell us a bit more how this is utilised in the wider office?
Yeah, I think it's quite good. The use of sort of computational tools and patterns. I think this section I thought we'd talk about. So patterns is a good sort of analogy to that, and how we utilise patterns and ideas, and connecting that to how, I suppose, expanding that to access for all, I suppose, along the way. So computational tools, I think, in this area just require a different way in approaching the design, I think, and a different way of working, which recent graduates are probably more familiar with. But one approach we've taken in the office is to try and include the wider audience in that computational design workflow. And patterns are probably a really good example of how that is. So this is utilising, as you said, the usual in colours and to define sort of facade types along the way. We've been working on this for a number of years, but this started with that office building I showed earlier. But in the latest building, we've actually decided to make those colours available not only in the application itself, but outside of the application within Excel. So this example is an unwrapped elevation, obviously, and what that does it allows anyone on the project to easily open the file and change the colour of a cell, and in turn it'll actually change the facade panel that might be attached to the building, say a glass panel, or in this scenario it might be a different configuration of fins or something else. And this is a typical example of the elements that we actually use to place on those colours. And you can see it really opens up the bottleneck that can sometimes occur where you have a specialist in the office where you have to wait for them to actually do something to make a change to the building along the way. Another area we've been looking at within that is sort of the recursion, I suppose, and how we can utilise that with the general staff with a little bit of general understanding about how computational design tools work. And I think one of the most powerful automation tools is when you can get the system to do some analysis for you and take a course of action, which is sort of where Recursive sort of comes from, I think. So this is a landscape plan that we developed, one of our team members sort of created by hand, I think, a few years ago. And it does have some unique features that have been placed in there along the way, but it posed to me a question: how could you create something like this that actually could be generated sort of computationally, I suppose, along the way? So with a bit of code and a lot of help from Volker and the team on the forums, we started to develop a recursive script that did ask a couple of questions. And the questions were, is there if this B-spline crosses over a polygon? And if it did cross across a polygon, then let's subdivide that polygon up and then check again to see if that polygon, V-spline still crosses that polygon. And if it does, let's keep subdividing this until we get to a certain size. And then the results we get are something like this, which I think is quite effective and starts to get that feeling of that design plane that we actually had on. But then I asked my question, well, if we can do it with one B-spline, let's do it with two. Why not do it with two? And then, well, let's have a look at it in a graphic format. So here we're basically just saying, well, let's colorize those polygons based on their areas, so we can get darker polygons based on their size. And then if we can do that, well, why not throw in some randomization into the script and say, well, let's randomly pick some polygons and subdivide those as well. And then finally, sorry, it's a little hard to see, but then finally let's randomize the edge length of these polygons and get some random shapes out of it. So, and we could just keep going, I think, and find different solutions. But at the end of this exercise, I think the result was that we ended up with a script and a methodology of the future of how you could develop something that for any project in our office that just had two simple inputs, a polygon and a B-spline, and it'll generate a paving solution for you. So I think it's a really powerful tool to actually start to develop those tools, patterns and recognition to give the wider audience a way to integrate into the computational design workflow.
Yeah, no, it's interesting. Repetition and recursion, very powerful stuff there.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.